Hello everyone. In this video I'm going to speak about how we can write a chemical formula. Let's get started. Writing a chemical formula is very important in all our chemistry topics. For that reason, in this video I'm going to focus on how we can use the periodic table to write a proper chemical formula. If you are writing a chemical equation, before balancing it, you have to make sure that the formula for the molecules or the compounds are correct. Let's see what we should do. First of all, here is the periodic table. And you will be given the periodic table, paper 1, paper 2, it doesn't really matter. You have here the groups. What should you do in the beginning? You have to say that, okay, this is group 1, so it's 1. Its valency is 1. What's mean by 1? It will lose 1. 2 is 2. Then you leave the transition metals. Why you leave them? Because the transition metals, they have various oxidation numbers. And they will be given, like here, iron 3 oxides or iron 3 chlorides. They will give you the oxidation number for the transition metal that you have. So you don't have to worry about the transition metals. They will give you the oxidation number or the valency for the metal. But you have to always remember that they are metals. We don't have a negative charge. They are always positive. So iron 3, it means iron 3 positive. Then we'll move to group 13. So it's 3. They will lose 3. Then group 14, they are 4. Starting from group 15, you have to think group 15. So elements have 5 electrons in the last shell. So they will gain 3 or lose 5, of course, they will gain 3. So from here we have 3, then group 16. So all the elements here in group 16, they have 6 electrons in the last shell. So they have to gain 2 to make the last shell full. Then 17, of course, 1 because they have 7 electrons in the last shell. So they have to gain 1 electron to make the last shell 8 as the noble gases. Here, the group 18, they are 8. They are full. Okay, this is how you should see the periodic table whenever you are writing any chemical formula. We have said before that we have common ions like ammonium hydroxide, hydrogen carbonate, nitrate, carbonate, sulfate, and phosphate. And the most important thing that you have to know about the common ions is their oxidation or valency that is given here. Okay, away from that, if you are told that, if you have been told that you need to write lithium chloride. Where is lithium? Lithium is here, is in group 1. So you're writing Li. Chloride, Cl. Okay, so it's 1. So Cl. What is the valency for lithium? Is 1. What's the valency for chloride? Is 1. So we need to exchange the valences. How we exchange the valences? This one should come here, and this one should come here. So it is LiCl. It is LiCl. Here is the formula for lithium chloride. What about magnesium chloride? Magnesium is Mg. Chloride Cl. Magnesium is in group 2, so it's 2 here. Cl17, so it's 1. Exchange the valences. So here and here, so we have MgCl2. This is how we should write magnesium chloride. One more example. Sodium nitride. Sodium is in Na. Then nitride, we have N here is in group 15, so it's N. Sodium is in group 1. Nitride is in group 15, so it's 3. Now we need to exchange the valences. So 3 will come here and 1 will come here. So it's Na3N. This is how we write sodium nitride after exchanging the valences. Aluminium sulfide. So we have Al and sulfide S. Al, here is Al, group 13, so 3. Sulfide is here, group 16, so it's 2. Now exchange the valences. So it's Al2S3. Very easy. More examples. Potassium oxide. Where is potassium? Potassium is K. It's here, group 1. So K, oxide, oxygen. Here is oxygen. Is in group 16. So we have 1 and you have 2. Exchange the valences. So it's K2O. This is how you should write potassium oxide. Calcium carbide. What's that? Calcium, Ca is carbon. Carbon here. So C. So calcium is 2. Carbon is 4. Here it is, we need to do one more step, which is we have to simplify those numbers. So we'll divide by 2. So we have here 1, divide by 2. So we have here 2. And do the same, exchange the valences. So it will be Ca2C. We don't write 1. This is how you should write the formula for any compound or any molecule that you have. It is very important before balancing a chemical equation is to write the correct formula for the molecules or the compounds that are found in this equation. Very important to use the periodic table that you have properly. As you can see here, whenever you are given the periodic table, you have to write those numbers. You need to always realize that you have group 1, so they will lose 1. Group 2, they will lose 2. Group 13, so they will lose 3. Group 14, yes, we have spoken about that before. They are making covalent bonds, so they still have 4 electrons in the valence shell. Group 15, so you have to think, group 15, they have 5 electrons in the last shell, so they will gain 3 so that they can have 8 electrons in the last shell. Same with group 16, they have 6, so they will gain 2. Group 17, they have to gain 1 to make the last shell 8. And this is how you should write the formula. Another important thing when you are writing the formula is to see something which is very interesting. When you have an ion that ends by ide, it means that this is the ion that's coming from the pure element. What does it mean by that? It is the nitride is the nitrogen ion, N3 negative. Sulfide is sulfur ion, so it is S2 negative. Chloride, Cl negative. Oxide is O2 negative. Carbide is the carbon positive. For positive. It really depends on the other ion. For carbon, if it is more electronegative or less electronegative, then carbon will be positive or negative based on that. But away from that, when you have an ion that ends by ide, it means that it is an ion that's coming from the pure element, not a polyatomic ion like here. Nitrate, it's a polyatomic ion. It's not the pure ion from nitrogen. Also sulfate, it's not only sulfur. No, it's sulfur with oxygen. Phosphate, it's not pure phosphorus. If it is pure phosphorus, it has to be phosphide.